Hi, and this is Peter, and I recently found this feedback item here. I believe it's the second most voted item in the profiling and optimization section. And this guy says that Unity's math library is using custom constructors in most of its methods, for example, vector multiplication, division, scaling, and so on. And he says replacing the custom constructor call with this code here brought back a lot of performance for him. So he said that in his tests previously it was about 90 milliseconds and it's down to 2.5, which is a lot. And I thought it would be interesting to find out how this change affects performance in a actual project, in a complete project, rather than just one test, synthetic test like this. Anyway, I did this test myself, so in this case I have this test code here and it's doing a lot of vector nonsense. It's doing vector addition, multiplication, normalization, and computing the length. And what I would like to show you now is that I built the project, open it in a profiler, see how fast it is, run the ILpatcher I wrote, and profile it again to see how it affects performance, and then I'm going to show you what the ILpatcher or ILoptimizer is doing, why it is doing what it does, and yeah, and that's it. So let's first create a build, build and run. Okay, that's strange. Let's maybe just build and run again, and the second time it works. Maybe. Yay. Okay, awesome. So this, what we are seeing here, is the code that runs here. So nothing special. Let's connect with the profiler and get rid of the errors. Profiler, record, and the code should be located here. Test code 1 update. It's about 34 milliseconds fast or slow. So let's close this one, and I'm going to show you the reflected code that you can see that it gets replaced. So the Unity Engine.math class is stored in this core module here, and if we go to the vector 3, Unity Engine vector 3, and let's pick what do I use? Vector 3 magnitude or vector 3 normalize. Vector 3 magnitude, that's not very interesting. Vector 3 normalize. Okay, this is interesting. So in Unity's code, the vector 3, the static vector 3 normalize method is calling the static vector 3 magnitude method. Then it's calling, this is called the division operator, which is this one. So this code here, and this code again calls the custom constructor to set the fields. So back, and otherwise it just returns a zero vector. And if we look at the ILpatcher definition with the code we want to use instead, it's static normalize here. So we have the inlined magnitude call, the inlined division, and the inlined vector 0 basically. So then let's just run the tool now. I believe I already prepared it. Yes, that's the directory. Hit F5, compile and run. So it now scans or reads all the assemblies in the directory and overrides them with the patched code. And if I switch back to this tool, and now I'm going to hit F5, and then it reloads the code, and you should see the changes. So I hit F5 now, and that's the code in Unity's core module now, but it's the code that we defined in our own code here. So math f square root greater than, and that's exactly the code here. So now let's just run this build again and see how it affects performance. Okay, record, and it actually is faster. So 30, 34 before, and now 25. So that's a huge improvement for such a simple change. Yeah, so absolutely awesome, right? No source code in your project had to be changed to make this code run about, I don't know, what is this, 30% faster or so? No, not really. So the idea of this tool is that I can define types in this project and methods in this type, and the instructions generated for this code are basically just copied over in Unity's assemblies or Unity's DLLs for this specific type and method. So in Unity it's Unity engine.vector3, and in this project it's just called vector3. When this gets compiled and run, I take the IL code from this method and copy it over into Unity engine.vector3 normalize. So that's pretty simple. I used this approach to just copy the IL because I started by implementing or writing the IL directly, and it was much harder and took a lot longer than this approach. So that's pretty cool. I can just define all the code here, and it gets copied over to Unity's assembly. And this code is basically just reading all the DLL files in the source assembly directory, uses, I believe you pronounce it monoCecil, to load the assembly, call the module definition, and then it checks if this module contains a type called, for example, vector3, and if it contains a type called vector3, then it tries to copy all the code that can be found in this class here, which is part of this project. It's this code here, over into this vector3 and in each method body. So that's, and then saves it in the directory, but that's pretty clear, I guess. Yeah, so that's how the tool works. Yeah, and I think the conclusion is it would be pretty cool if Unity could patch or could update their mathf class to use object initializers rather than custom constructors, and inline a few calls, so there's no need to call vector, I believe vector normalize or vector dot, just inline. It's simple code actually, just inline the method, and every application on this planet that uses Unity gets immediately faster. Yeah, so that would be very cool. On the other hand, with Unity 2018, they introduced the C# job system, and you probably won't have code like this, or you would use the job system for that. But anyway, I mean, it's a trivial change in the code to replace the constructor calls and inline a few methods, and every project runs faster. So this test runs a lot faster. My actual project that I tested, it's a complete game and it runs about 4% faster. I mean, it's still a lot for basically no change in user code, just replacing a few method calls in the Unity DLLs itself. So yeah, 4% also really good. Anyway, okay, let me think, let me know what you think. I'm not really sure. I would like to put this project on, I don't know, Bitbucket or GitHub, but I'm really not sure if Unity likes the idea. So if somebody from Unity gives their okay, I'm going to put it on GitHub, and you can use it, do whatever you want with this. Yeah, but otherwise I'm not going to share it. So I guess that's it. See you.